Hello class, welcome to the second half of our lessons for section 1.4. Section 1.4 deals with trigonometric functions and their uses and definitions. Remember, we're looking at reciprocal identities and things like that, finding x, y, and r, for example, and finding all 6 trig functions. So hopefully some of your homework will make a little bit more sense after going through this lesson. The first question we're going to look at kind of looks like what we ended with last time, which was giving you a trig function and then saying what quadrant it was in. This question doesn't say what quadrant, but it is disguised as the same idea. So first off, it says cosecant of theta equals -2. If you're asked to find all the trig values, first off, if cosecant is -2, that's -2 over 1. You should never miss the reciprocal, which in this case would be sine. You flip it and it's -1/2. That one you should be able to get regardless of how much you know extra, okay, for this question, because at least you know the reciprocal identity. The trouble with this question is it says cosine is greater than 0. So if cosine is greater than 0, what you need to look at is the fact that cosine is positive, but then also sine is negative. So cosine positive because it's greater than 0, and sine is negative because they tell you it's negative. And then you're looking to where that happens. Well, cosine's positive either in the A category, all, or the calculus, the C category. And because sine is negative, it has to be quadrant 4. So that right away says, oh, my picture's in quadrant 4 then. What you have in this case then is the fact that 1 is the y value, so -1 goes here, and 2 is the hypotenuse. From there, do Pythagorean theorem, find the missing piece. You're going to be doing a lot of Pythagorean theorem in the next couple weeks, so keep track of that. So then x is √3. Notice x is positive, y is negative, and then from there you just find all the trig values. So all the trig functions are right here. You'll notice if cosine is √3 over 2, then its reciprocal secant is 2 over √3, and you have to rationalize. You'll also notice that sine is negative and tangent's negative, but cosine's positive because it's in quadrant 4. I'm not going to go through every single one of the trig functions because you should be able to kind of look at it and see based upon x, y, and r what the answers are going to be. But if you have any questions, please let me know and I'm happy to explain them in more detail. The next question is definitely focused on a calculator. We kind of looked at one of these before that had a decimal to start with. The rule of thumb is put it over 1. And now you have an x and a y, for example, in this question because it's tangent. The nice thing is they tell you it's quadrant 2, and in quadrant 2, the x value should be the negative. So don't get stuck on the 1.46 being the negative because it could have been the 1 on the bottom that's negative. I will be honest that the book and your homework typically goes into great detail about this question. That's really unnecessary because it's just the same idea. Just put it over 1 and then do Pythagorean theorem and find r. And then from there, you'll have two decimals that you're dividing out. You're going to want to find those final answer pieces and then just flip them to take the reciprocal to find the other 3 trig functions. It's actually a pretty easy question and actually easier for you because you don't have to worry about any rationalizing. So there are some benefits to the decimal questions and finding all 6 trig functions. But just remember to put the original decimal over 1 and that should help you find your answer. Okay, the next thing to discuss is to kind of reevaluate some of the quadrantial angles. I will tell you, make a note to yourself, you need to be able to explain these types of questions pretty well. There'll probably going to be some homework checks over some of these types of things. So make sure you're able to explain, for example, that sine of 180 is 0, and here's why. At 180, you're over here to the left on the x-axis. Sine is y over r, and the y value is 0, and 0 divided by 1 is 0. Tangent of 270 would be straight down here. It would be y over x, and y is -1, x is 0. -1 divided by 0, undefined because you can't divide by 0. So if you try plugging in tangent of 270 into your calculator, it'll probably say there's an error of some type. You might want to try that and make sure your calculator is doing what it's supposed to do. We'll have to look at that in a little bit more detail later with the setup of your calculators, but it should be undefined. If I was looking at cosine of -450, I would just go around 1 time, so start at 0, go backwards 1 time, and then add another 90, and that puts me down here at 270. The other way is you just keep adding 90 until you get to be a positive like you did in homework 1, and then cosine would be the x value over the r value, which is 0 over 1. Cosecant of 630, subtract 360 until you get to 1 time around the circle. That's the same as 270. The r value over the y value. The r value is 1. the y value is -1, and that would be -1. But you want to make sure you're able to explain the quadrantial angles using x, y, and r and be able to write it out. Okay, you might have to look at that later on. So make sure you're able to explain them. If you're not sure, make sure you ask about it so that you can explain those answers. The next question is a really easy algebra question as long as you understand the reciprocal nature of things. So this question says sine of something is the same as 1 over cosecant. Well, if you understand the reciprocal identities, 1 over cosecant is the same as sine. So that essentially means that these two inside pieces, 3x plus 2, or 3 theta plus 2, excuse me, is the same as 11 theta minus 12. Remember, theta represents an angle in most cases, especially in trigonometry. You could probably guess that you should set them equal to each other. What you don't want to do, though, is set them equal to 180. Okay, they don't add together to equal 180, so make sure you set one equal to the other. I didn't bog down with the details of solving for theta at that point. It's just moving things around and getting theta by itself. The one thing I will mention is sometimes the numbers don't work out, quote, nicely, and you'll want to make sure that you are rounding to the correct spot in order to be successful on your homework. The last thing that I want to discuss is just looking at graphs of the sine function and the cosine function. Not that it's a big deal right now, but we are going to be looking at the sine and cosine graphs later. So anything you can do to memorize this graph, I know that if it's virtual or things are online, it's kind of less of an issue, but you still want to know the basic ideas of the sine and cosine graph. So you need to start memorizing this graph and understanding what it's saying. Here's what you're looking at. Oh, sorry, there was the cosine graph for a moment. The sine graph starts at 0, 0. At 90 degrees goes up to 1, which is the quadrantial angle at 90 degrees. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1, and sine of 360 is 0 because it matches up with its coterminal angle of 0 degrees. You'll notice here I also put in these Roman numerals. These represent the quadrants. This says in quadrant 1 and 2, notice the graph is above the y-axis. That means it's positive. And in quadrants 3 and 4, it's below the y-axis, which means sine is negative. So it does the same idea as all students take calculus. Some teachers and students like to use the graphs more. I personally learned how to use the graphs first, but I think either option will work for you. No matter what option you pick, you still want to be able to understand the graphs. And so make sure that you understand what they look at. They focus on what's positive and what's negative, and what the quadrantial angles are doing. That could be more beneficial, actually, sometimes maybe than the unit circle idea. The cosine graph, you'll notice, does not start at the origin. It starts up at 1 because at 0 degrees, the x value is 1. So that's why it starts here at 1. And then it goes down to, at 90 degrees, cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. And cosine of 360 is 1. And then it repeats itself. It just makes a wave back and forth, because its coterminal nature of the graphs just keep going around in a circle. You'll notice here that quadrant 1 and 4 are positive because quadrant 1 and 4 are positive for the x values, which means cosine is positive. And then cosine is negative in quadrants 2 and 3. You could use these graphs to help find tangent because tangent is sine divided by cosine. So for example, if I wanted to know if tangent was negative in quadrant 2, sine is positive in quadrant 2, so sine is positive here. So a positive divided by a negative is a negative, which corresponds to tangent being negative. I probably won't focus too much on the graphs unless you have for at least figuring out what's positive and negative. You're going to want to know the graphs. In chapter 4, I believe, is where the graphs come into more of a play. The fact that we can look at them earlier and start to know them is a good thing. So you want to start knowing those graphs. I know it's hard with virtual pieces especially, but you do want to start knowing what those graphs look like in order to be successful on graphing later on. So this goes back to the trig functions, just knowing the signs of all of the 6 trig functions here. So 162 is in quadrant 2. That's obviously where the S is in all students take calculus. You can revert back to the previous notes in order to figure that out. The other option is 162 is in quadrant 2 using the graph, so it's positive for sine, negative for cosine, which means tangent has to be negative as well. Negative 380 goes in quadrant 4, so that's where cosine's positive and the others are negative. That would correspond to sine being negative, cosine being positive. It's just another way to set it up. Just make sure you stick with one of them. I know a lot of you will just use this device here with the all students take calculus. Just make sure the graphs are being kind of looked at in the background to make sure that you understand how to use them. This one says that sine is positive because it's greater than 0, tangent's positive. I would probably use this device to find it. You could also use the graphs and saying that, okay, well, sine's positive. Well, that corresponds to quadrant 1. This one's a little bit more challenging because tangent's not one of these two graphs that you looked at to begin with. Okay, you can still find it though using the device here. And sine being positive, tangent positive means it's in quadrant 1. Remember, if you're looking at secant and cosecant, you should always flip-flop. Okay, know sine and cosine really well. So cosine is negative. That happens in quadrant 2 and 3. But sine being positive has to mean that it's in quadrant 2. So I think that device with the All Students Take Calculus is probably the most helpful. Please make sure you look at the graphs, though, and make sure you start to know them. I think they could be more helpful, actually, on quadrantial angles and knowing, like, sine of 0 is 0 in case you struggle with the x, y, and r principles. Obviously, if you're looking at some notes and things like that, that's less of an issue on an assessment, but still make sure that you're looking at those pieces as you move forward. And that's everything for this lesson. Make sure those graphs are being looked at. Make sure that you're understanding how to know if things are positive or negative, because even with a calculator, those things will become more helpful. Have a good day, everybody.